Okay, this is lesson 3.3, solving systems by adding or subtracting. Hopefully you've watched a few videos before this, and this isn't the first video that you're watching. However, if it is and you've gone out of order, you want to make sure that you go back to some of those other videos to get more practice and see other types of equations. We are going to discuss the elimination method in this lesson, in which you solve systems by adding or subtracting, which will include eliminating a variable through that addition or subtraction. When we eliminate one of the two variables, we'll be left with a single variable equation, and then we can solve for that variable and get our solution to our system. Now there's 3 steps that we're going to take. The first one is adding or subtracting the equations to eliminate one variable. So I'm going to show you an example that's going to do each of this, add and subtract. But first we want to make sure that we have our steps down. First step is add or subtract the equations to eliminate a variable. The second step is to solve that resulting equation for the other variable. That means solve for that variable, get some kind of a numerical value for the remaining variable. Step 3, we substitute that value into an original equation, just as we did with the substitution method, to solve the system. Now I'm going to go step by step. I'm going to try and remember the highlighted colors that I've used. First, I'm going to rewrite my equations. 4x minus 2y equals 12. X plus 2y equals 8. And my first step is add the 2 equations together. So I'm going to take these 2 equations and I'm going to add them. This will be my first step in solving. 4x plus 1x is 5x. And when I add the 2 equations, negative 2y plus 2y is eliminated. Negative 2y plus 2y is 0. Therefore, the y variable has been eliminated. And 12 plus 8 is equal to 20. Now we need to take the remaining equation, or the resulting equation, and I need to solve this equation for x. So I'm going to divide both sides by 5, and I get x equals 4. I have half of my solution. I have the x value of my solution. Now I need to take this value of x. I need to take this value of x, and I need to substitute it into one of the original equations for x. I'm going to choose to substitute it into that second equation, in which case I have 4 plus 2y equals 8. I'm going to subtract out the 4 from both sides, getting 2y equals 4. I'll divide both sides by 2, and I get a solution for y in which y is equal to 2. So the answer would be x equals 4, y equals 2, or most commonly we show it as an ordered pair. Now, we can check our solution by graphing, and it's a good idea to do this. I'm going to graph the first equation, 4x minus 2y equals 12, by using intercepts, x and y intercepts. I want to find the x-intercept, so I'm going to put a 0 in for y. When I put a 0 in for y, I end up with 4x equals 12. I divide both sides by 4, and I get x equals 3. So the x-intercept is 3, and we typically say the x-intercept is 3, 0. Now, the y-intercept of this same equation is when I put a 0 in for x. So I have 4 times 0 minus 2y equals 12. Negative 2y equals 12. Divide both sides by negative 2, and we get y equals negative 6. So the two ordered pairs that I need to plot. So what we have is we have an ordered pair at 3, 0, which is our x-intercept. And we have an ordered pair at 0, negative 6, which is our y-intercept. And we can connect those 2 points to make a straight line. Just as if we were making a table. When we make our table, we plot our points, and then we connect those points using a straight edge. I'm going to make this line blue, because the other line that I make now is going to be red. So x plus 2y equals 8. I'm going to scroll down a little bit here. X plus 2y equals 8. I'm going to find again my intercepts. I'm going to find my x-intercept. The x-intercept is the value of x when y is 0. So we have x equals 8. So when y is 0, x is 8. So that gives us an ordered pair at 8, 0, which is our x-intercept. Our y-intercept is the value of y when x is 0. So I'm going to put a 0 in for x. 0 plus 2y equals 8. Therefore, y equals 4. So we have 0, 4. So our ordered pairs are 8, 0, and 0, 4. I'm going to use a straight edge to connect those 2 points. And you can see, before I even make that line red, that the location of their intersection is at the ordered pair 4, 2. Now this shouldn't be a surprise, because if we look back at the algebra solution, our ordered pair was indeed 4, 2. Now let's look at an example where we're going to solve a system by subtracting. I have 2 equations that I'm going to consider together on the same coordinate grid. And I have 2x plus 6y equals 6. And I have x minus y equals negative 8. Now if you watch the other videos, you know that we need to multiply here, because if I were to add these 2 equations together, I would not be eliminating any variables. So I would end up with a sum of the 2 equations that still had both x and y. And that is what we want to avoid. So what we need to have is values in which the coefficients are the same, so that a variable can be eliminated. So what I'm going to do is I'm going to multiply this second equation by 2 using the multiplication property of equality, back from Unit 1. And I have 2x plus 6y equals 6 is the first equation. The second equation becomes 2x minus 2y equals negative 8. Now typically you'll be taught to add the 2 equations, but sometimes you can subtract the 2 equations. And well, you can always subtract the 2 equations, but sometimes it's easier to just subtract the 2 equations so that you don't have to multiply by another negative value. So if I subtract these 2 equations, 2 minus 2, the x variable goes away. 6 minus negative 2. 6 minus negative 2 becomes 8y. And 6 minus negative 8 becomes 14. And I made a mistake here. I need to go back and correct that. Now, when I multiplied by 2, this is why it's probably important for you to show your work. 2 times x, 2 times y, 2 times negative 8, which would not make that negative 8. We would end up with negative 16. So let me fix that right here. I would have negative 16 right here. 2 times x is 2x. 2 times negative y is negative 2y. And 2 times negative 8 is negative 16. So when I subtract these two equations, 6 minus negative 16, that's 22. 6 minus negative 16 would be 22. I'm going to divide both sides by 8. I'm going to reduce my fraction to become 11 over 4. Now I need to substitute that value back in, and I love that this is a fraction because we should not be afraid of fractions. I'm going to substitute that back in. I'll do my substitution in purple. X minus y is 11/4 equals negative 8. Now remember, we can eliminate the fraction here. We can eliminate that denominator by multiplying everything in the equation. So multiplying that entire equation by 4. 4 times x would give me 4x. 4 times 11 over 4. 4 times 11 over 4. Well, the 4's cancel out, and that gives me 11. So we have 4 times x is 4x. 4 times negative 11/4 is negative 11. And 4 times negative 8, notice how I'm not going to make that mistake a second time. 4 times negative 8 is negative 32. And again, I love that this came out to be a fraction so that you can see how we can clear our fractions. It's always helpful when you can review what you've learned. I'm going to add 11 to both sides, giving me negative 21. Therefore, x is equal to negative 21 over 4, and y is equal to positive 11 over 4. Now, if we tried to solve this by graphing, we would not land on a lattice point. I'm going to pull up the graph for you and show you that we would not land on a lattice point. The reason we would not land on a lattice point is because we would have some fractional amount. So we would end up with an intersection point at negative 21 over 4, which is about negative 5 1/4. And then the y variable was 11/4, which is 2 3/4. So the intersection would end up right there. And unless we have solved this algebraically, we won't be able to estimate where in this box that point lies. So when we are finding that intersection point, because it's not on a lattice point, we would be forced to do this problem algebraically, in which case we've done right here, and our answer is negative 21 over 4, comma 11 over 4. Make sure you watch those other videos because there are very, very helpful problems and instruction that are in the other videos. Please don't skip over those links. Make sure that you've watched them. Doing this lesson alone is definitely not going to be enough for you to master this concept. I hope you found this video helpful, and we'll see you in the next lesson.